Now we're going to look at annuities. An annuity is a sale. This is the difference. With an ordinary annuity, each payment is made at the end of each period. Whereas with an annuity due, the payments are shifted forward in that the payments occur at the beginning of each time period. So with these two timelines, we have a 3-year annuity, 3 payments. But with the ordinary annuity, each payment is at the end of each period, at the end of each year. Whereas with an annuity due, you're still receiving or paying only 3 payments, but they occur at the beginning of each time period. And in terms of the time value of money, that makes a difference. I will tell you that most annuities in the real world are ordinary annuities. We can find either the future value or the present value of annuities. In this lecture, we're going to look at finding the future value of annuities. And we're going to start with finding the future value of an ordinary annuity. So we're given a 3-year ordinary annuity of $100 at 4%. So that means at the end of each time period and end of each year, $100 is going to be paid into an account paying 4%. At the end of year 3, we want to know what that series of payments or deposits has grown to become. So rather than one singular lump sum, we have a series of payments that are equivalent to one another. So in this case, N is 3, our interest rate is 4. We have no present value, but we do use the payment key because the payment key is reserved for annuities, that series of equal payments. And our payments here are $100 each year. Here, they've changed the sign, assigned a negative sign to the payment, and solved for future value. And the future value here is $312.16. Remember, something has to be a negative, or you have to change the sign for your calculator to work. Since there's no present value, you could assign either payment the negative sign or just let future value be the negative sign. Let it solve for you, and your display will be negative. You will just disregard that negative sign. So let's look at another problem. We've got a 20-year-old. She invests $1,825 every year into a brokerage account. That returns 8%. We want to know when she turns 65, what will that series of deposits have grown to become at 8%? Okay? So we know what the payment is, what that annuity payment is. It's $1,825. We know the interest rate, it's 8%. We're solving for the future value. That's what we're computing. There is no present value. What's in? How many of these deposits will she make? She's 20 today. We want to know if she makes this deposit every year, how many deposits will she have made by the time she's 65? The answer is 45. So after she's made 45 deposits into this account, paying 8%, 45 deposits of $1,825, the future value is $705,373. Okay? What if she doesn't start this savings plan till she's 40. Everything stays the same. Her payment is still $18.25. The interest rate offered on this account is 8, but she's not making as many payments. She doesn't start this series of deposits into this brokerage account until she's 40. So that means that N is only 25. So when she turns 65, her series of payments has grown to become only $133,418. That is a huge difference. And if this problem shows you anything, the lesson learned is it pays to start saving early. Now, let's turn things a little around. What if we keep the time period the same? What if this investor doesn't start saving till she's 40? We want to know over the 25-year period when she turns 65, what would she have to deposit to end up? What would be her annuity deposit every year for 25 years so that she can end up with $705,373. She's going to have to invest every year a whole lot more than $18.25. So what we don't know here is the payment. We know the time period is 25 years. We know the brokerage account pays 8%. We know what she'd want to end up with, but we don't know what would be the increased payment to make this happen. Wow. When we solve for this problem, it's a huge difference. If this investor doesn't start saving till she's 40, she would have to put aside every year over $9,600 to be able to end up with at retirement that $705,373. So all of those problems are ordinary annuity type problems. Finding the future value of an ordinary annuity. Well, what about finding the future value of an annuity due? How do we do that? Well, in this case, going back to the original problem we worked with, $100 over 3 years at 4%. We ended up with a future value of an annuity of $312.16. Well, if this same setup, instead of an ordinary annuity, if it's an annuity due, how do we change this? Our payments are occurring a whole period earlier. They're occurring at the beginning of each time period. It really isn't that hard. There is a way to solve it with your calculator, but you have to change the mode, and you got to make sure you put it back to the original mode. I think the easiest way is just taking the answer to the ordinary annuity, multiplying it times 1 plus the interest rate, and voila, you get the future value of an annuity due. Here's a problem that I've worked for you. If you click this link, one problem where in the first part you solve for an ordinary annuity, and in the second part you solve for an annuity due.